Okay, so for the last part of our meteorology unit, for the questions, uh, the wind direction, so that happens due to the friction, which is like mountains or hills, on the Earth's surface. So the wind will always be 180 degrees across, so straight across, from where the friction is. Uh, and you can see on that bottom picture, the green one, how the friction, where those mountains are, the wind is straight the other way. So straight 180 degrees. And then the Coriolis effect, which we'll learn about in the next slide, is 90 degrees away from the direction of the wind. So 90 degrees cuts it straight in half. The first picture, the lighter blue one, shows a really good angle diagram of the friction and the wind, and then how the Coriolis effect is in there. And then understanding the Coriolis effect, we had to know that our Earth is tilted at a 15-degree angle. So it's not rotating straight on, the very bottom of the Earth, if you think of it as a ball. Because of this 15-degree tilt, that makes the wind move in a right angle. For air rising and falling, we know that cold air descends. And we know this because when the temperature drops, the molecules in the air take up less room because those molecules aren't vibrating as much. And that causes those molecules to fall. And vice versa, we know that warm air rises because when the temperatures rise, the air molecules take up more room due to them vibrating more, which increases the size around every molecule, which makes them rise up. Circulation on climates. So after this slide, I also have a good picture that helps make this a bit clearer. So the general circulation impacts climates because the circulation brings about high pressure and low pressure zones. High pressure zones create cold temperatures while low pressure zones create warm temperatures. So we can see with the winds happening and all of that, how it changes the climates all over the world. So in an idealized Earth, that is talking about a Earth that's at a just straight up and down with no tilt, we can see that it's pretty clear what the climates are. It's not as distorted as the second image of what our Earth actually looks like. So once we get closer to the equator, right there in the middle, it's hotter there. And that is a low pressure zone. And then the higher and higher we get towards the high pressure zones, right at the polar North Pole and South Pole, those create those cold temperatures. And then this is just kind of to show the Earth broken in half, so we understand it has the summer wet, winter dry, has all of that, and I think that it's really helpful to know that to understand the circulation of the climates.